Okay, here we go, guys. Pre-calculus, section 9.6, page 659 for homework, counting principles. Using fundamental counting principles, combinations and permutations to solve counting problems. So there's a theorem, a principle called fundamental counting principle. If event 1 has m ways of occurring and event 2 has m2 ways of occurring, then there are m1 times m2 ways that these events can occur together. Okay, so we'll discuss that in a little bit. But basically, that breaks down, for example, if you were to come into a small hamburger restaurant, okay, and there's 5 different hamburgers you can choose from, and 2 sizes for drinks, regular and large, then that means for you to order a hamburger and a drink, there'll be 5 times 2 ways, 10 total ways that you can order a hamburger and a drink. Okay, so permutations, that's the next thing we're going to talk about, is an arrangement of items where the order does matter. Okay, so when you're arranging items, okay, and when the order counts, as in you flip-flop them, it's totally different, then that's called permutations. So NPR, so there's a subscript n in front and a subscript r in the back. That formula is n factorial over n minus r factorial. Combinations, on the other hand, is an arrangement of items where order does not matter. NCR, again, n in front, r in the back, n factorial on top, n minus r factorial on bottom, and r factorial on the back of that. Okay, and then permutations with repeats. Basically, here is when you're arranging items that have that you have multiple items of each. So if there are n items repeating and m items repeating, right? So it'll be the total factorial over each repeat factorial. So we'll discuss that also. Okay, so let's do some examples, okay? So for example, let's say we want to we're talking about here, let's say we have suits, okay? We want to make we purchase a suit, okay? So clothing, suits. So let's say, for example, when we have these suits, we have there's rayon, right? There's wool. Let's say these two kind of fabrics, okay? So there's 2 choices here we can choose from, okay? And then in terms of color, we have gray, we have blue, black, and tan, okay? Just some random colors here. So there's 4 choices there. And then let's say we want to buy a tie along with that. So these ties, there's a floral tie, with flowers on it. There's a striped tie, not getting all fancy and stuff. And then a geometric patterns on the tie. Patterns, so geometric patterns, okay? So if you look at here, there are 3 choices here. So if I wanted to see how many different suits I can choose from, how many different types of suits. So I would first choose the fabric. There's 2 choices. And then I would have to now decide, okay, with these fabric, what color would I like? I would like, there's 4 choices there. And then now to get a matching tie, let's say. Okay, there's 3 choices there. So in total, there's going to be 24 different, okay, suits I can purchase. Okay, there you go. That's what that means there. Okay, now here we're talking about how many ways can you arrange 5 math books on a shelf. Okay, So let's say you have an algebra book, algebra 2 book, a geometry book, a trig book, and a pre-cal book. Okay, so these are 5 books. So how many ways can you rearrange these on a shelf? Okay, so here's how you do that. There's 5 books, so you need 5 slots. Okay, so now you have all these 5 books in your hand. Okay, now how many of these books qualify to go in the first slot? Okay, so you have 5 books in your hand. That means you have 5 choices in the first location. Okay, so now let's say I put geometry first. Okay, so now it's on the shelf. Now I have 4 books in my hand, right? So that means I have, for the second slot, I can put any of these 4. I can choose from these 4. Okay, so let's say I put pre-calculus in there. All right, and then now I have 3 books in my hand. How many of these books can go in this third slot? 3 choices, right? So I have 3. So I choose algebra. Now there are 2 choices left. So let's say, well, I have 2 choices, either algebra 2 or trig. So I have 2 choices. I'm going to pick trig. So that's 2 choices. Okay. So now once I choose trig to go here, the only book that I have left is algebra 2. So that's the last one. So now if you multiply these, counting principle says just multiply them all. That's 120 ways I can arrange these 5 books. Okay. All right. So next example, let's say there are 7 students in a presidential race. Okay. Running for, let's say, ASB. There are 7 students running for ASB positions. Okay, and so we have, let's say, a president, right? President and a vice president. Okay, so we can do it in a couple ways. Again, you can do, again, here's president and here's VP, right? How many of these students can qualify to be a president? Well, all 7 of them could run, so we have 7 choices. So once you choose a person, a student, to be a president, how many are left? 6. So that's 42 choices. Okay, so you multiply those. All right. Or if you think about it in terms of permutations, okay, permutations or combinations, okay, you can think about it like that also. Okay, which one is this? Is this a permutation or a combination? You have to ask yourself, does the order of when I choose the person matter? Okay, the first person is going to be president, second person is going to be vice president. So choosing the order does matter, right? So this is strictly a permutation problem. So 7p2, 7 factorial, and on the bottom, 7 minus 2 factorial. Since the order here matters, the first name I call out is going to be president. The second name I call out is going to be VP. Okay, if I switch those, then that'll be different. So 7 factorial over 5 factorial, and that's going to be 42 again. Okay, so when the order matters, we're going to use permutations. Okay, so let's say we have 15 runners. Okay, we have 15 runners all together. Okay, so top 3 will go to CIF. Okay, top 3. So there's gonna be 3 winners all together. Okay, I want 3 winners. It doesn't matter who comes first or second or third. I have 3 winners. So now you ask yourself, does the order matter? Okay. Does having 3 winners in this race, okay, we're going to choose the top 3 winners to go to CIF. Does the order here matter? Okay. So when order does matter, we're talking about permutations. When order doesn't matter, then combination. So here we have 15. Order doesn't matter. I just want the top 3 people. I don't care who comes in first, second, or third, as long as I have 3 people. So I'm going to do C3. So 15 factorial, 15 minus 3 factorial, and then 3 factorial. That's 15 factorial, 12 factorial, and 3 factorial. 15, 14, 13, 12, 11, down all the way to 2 and 1. On the bottom, we have 12 factorial. So that's 12, 11, 10, 9, 8, 7, all the way down to 2 and 1. And then this guy is 3, 2, 1. So if you notice here, these cancel out. And then 15 and 3 cancel out, be 5. 2 goes into 14 7 times. So it's really 5 times 7 times 13. Okay, so that means I have 65 times 7, so 455 ways that I will get 3 winners from a race of 15 where the order does not matter. Okay, the order doesn't matter there. So what I mean by order matters or not, so let's say, for example, let's go back to that problem. I have 15 runners again, okay? But now I have 3 place winners, okay? 3 place winners. In other words, the first winner will be gold. Second is going to be silver. And third will be bronze. Does the order here matter? Okay. Does it matter if you come first, second, or third? Oh, yeah, definitely yes. Okay. So since order does matter, we're going to talk about permutation. So 15 P3. So 15 factorial, 15 minus 3 factorial. Okay. So 15 factorial divided by 12 factorial. So 15, 14, 13, 12, 11, dot, 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 all the way 2 and 1. On the bottom is 12, 11, 10, 9, 8, all the way down 2 and 1. Again, these cancel. So I have to multiply 15 times 14 times 13. Okay. So we have 15 times 14 times 13. That gives me 2,730 ways, okay, that I can have a first, second, and third place winner for 15 runners, okay? So make sure we understand that. Now, let's see. We have, let's say, permutations with repeats. Permutations with repeats. Okay. So, sorry. Let's say I want to reorganize the word wow. Okay, how many ways can I reorganize the word wow? Okay, so there's W, O, and W, but the thing is, I can't tell the difference between these 2 letters. They're the same. So how many ways can I rearrange the word wow? Well, there's wow, there's W, W, O, there's O, W, W. Okay, what other ways are there? There is let's see. Well, that's it, right? So that's the only 3 ways I can reorganize the word wow. So how I can compute that is I can do the total letters on top, okay, 3 factorial, and then repeats. So on the bottom, I'm going to put divide by repeats. So since W repeats twice, I'm going to do that. So here I get 3. There's only 3 ways I can reorganize the word wow. Okay, for example, mama. How many ways can you rearrange the word mama? Okay, then if you notice there's 4 letters total, but there's 2 M's and there's 2 A's, but you can't tell the difference between the M's and the A's. So let's rearrange the word mama. There's mama like that. There's M, M, A. That's 2. There is M, A, M. That's 3. There's A, M, 4. What else do we have? Then we have A, M, that's 5. And then A, M, A. See, these are the only 6 ways I can rearrange the word mama and make it look different, right? So again, I can do that by doing total letters on top. And then since there's 2 A's, these represent the A's, and then there's 2 M's. So there you go. So when I do that, I get 6 as my answer. Okay, so the total on top and repeats on the bottom. If I have the word cats, okay, cats. How many ways can I rearrange the word cats? Well, if you notice, there's no repeats here. There's no repeats at all. So it'll be 4 factorial. And on the bottom, I don't put anything because there's no repeats. So 4 factorial, that's my answer, 24. Okay, there's 24 ways I can rearrange the word cats. I can do C, T, S, A. I can do C, T, A, S. I can do, let's see what else. C, A, S, T. And I can do C, S, A, T, C, S, T, A. Right? So there's 6 ways right there. And then if I repeat this 4 more times, I will get 24. For example, I can do A, C, T, S, A, C, S, T, A, T, C, S, A, T, S, C, A, S, T, C, A, S, C, T. See? There's another 6. And again, I do this again with T in the front. Let's say T, S, C, A, T, S, A, C, T, C, S, A, T, C, A, S, T, A, S, C, T, A, C, S. There's 6. And then last, S, T, A, C, S, T, C, A, S, A, T, C, S, A, C, T, S, C, A, T, S, C, T, A. And then there's no other ways of rearranging the word cats. Okay, so in this case, there's 24. Okay, normally if there's repeats, I would divide down here. Okay, so that's how you do that. Okay, all right, have fun with that section.